In this video, we are going to look at how to find the equations of functions. We can find the equation of a parabola if we are given the intercepts, or we can read the intercepts of the graph and any other point. To do this, we use the intercept form. Y is equal to a, x minus x1, x minus x2. So first substitute in the x-intercepts. Here our x-intercepts are 1 and 2. Next, substitute in the point that we have is 0, 2, and then we solve for a. Once we have a, we substitute it back into the equation and then expand to write it in the equation in standard form. We can also find the equation of the parabola if we are given the turning point and any other point on the graph. So here we will use the turning point form. Y is equal to a, x plus p squared plus q. Substitute in the values for p and q. So remember, the turning point is minus pq. So here your turning point is minus 3 minus 5, which means that our value for p is 3 and our value for q is minus 5. So we substitute that into the equation. Then we can substitute any other point. So here we can see the point, the y-intercept, which is 0, 4. So substitute that into the equation and we solve for a. A is equal to 1. Now we add that or substitute that back into the equation, the turning point form of the equation, and we expand to get y is equal to x squared plus 6x plus 4. In this example, we are asked to find the equation of a hyperbola from the accompanying graph. So on the graph, we are given the vertical and the horizontal asymptotes. The vertical asymptote is at x equal to minus 1, which means that p is 1. The horizontal asymptote is at y equal to 2, which means that q is equal to 2. So we substitute that into the equation for a hyperbola. The other point that is given on the graph is the x and y intercept, so that is 0, 0. So substituting that into our equation, we find that a is equal to minus 2. So the equation of this hyperbola is y is equal to minus 2 over x plus 1 plus 2. And we can see from the diagram that the curve lies in the second and fourth quadrants formed by the asymptotes, which means it is correct that a will be a negative number. The equation for an exponential function is y is equal to a, b to the x plus q. There are three unknowns, a, b, and q. You may be given one or two of these unknowns and be asked to find the remaining ones. So in this example, we are given y is equal to a half to the x plus q. So we need to be able to find a and q. From the graph, we see that the horizontal asymptote is at 2, which means that q is equal to 2. We substitute that into the equation. On the graph, there is also one point that we can see, which is 0, 5. Substitute that into the equation and solve for a. We find that a is equal to 3. And once we put that into our equation, our answer is y is equal to 3 half to the x plus 2.